Okay, students, let's go ahead and go over your test one review here. Number one, which angles are a linear pair? Obviously, pair means there can only be two angles, and they must form a line, and they must be adjacent, which means next to. So 1 and 2, do they form a line? No, they don't. Do 2 and 3 form a line? No, they don't. Do 1 and 4 form a line? No, they aren't. Vertical angles. 4 and 5 form a line? Yes, they do, and there's only 2 of them, and they are adjacent. 3 and 5 do not at all. Which angles are vertical angles? We know that's 1 and 4. Which angles are supplementary? Okay, well, that could be 4 and 5 again. That's true. Is there another one? 1 and 5? That's also true. So therefore, it's B and C. Okay, now it's not multiple choice in a test. You'd actually name the angles with letters that would satisfy these conditions, for example. All right, find the value of y. Well, first I need to find the value of x. I know that these are vertical angles, so they're congruent. So go ahead and subtract the 2x across, and you get 2x. Add the 12 across, you get 20. So x is 10, so I can fill in the 10. 2 times 10 is 20, plus 8 is 28. So that's 28 right there. They form a linear pair, which means that they are supplementary, meaning they add to 180. So I have 7y plus 12 plus 28 equals 180. 7y equal, that's 40, subtract 40 across is 140, divided by 7, and you get y equals 20. C. Okay, it would not, again, it's not multiple choice in the test. You'd actually just solve for it and come up with C on your own. Okay, I'm just giving you some multiple choice so you can check your answers here. Solve for the missing angle. Obviously, these form a linear pair. They're adjacent and form a line. There's a pair of them. So 180 minus 144. Nice and easy. 36. It's amazing how many people still haven't had this memorized yet, and we've said it over at least 20 times in class. But it's because they don't participate in class again, just like I've already warned you over and over and over. All right, number 10 here. This forms a circle. How many degrees are in a circle? 360 degrees. So they all add up to 360. I got 3 G's plus 391, which is 273, adds to 360, a circle. Subtract the 273 across, and I get 87 degrees. Divide by 3, and I get 29 degrees, or G is 29. Okay, so that's what G is, 29. All right, number 4, two angles are supplementary. That means they add to 180 degrees. Two angles that add to 180 degrees. It says one angle has a measure that's 5 less than 4 times the other. So if one is x, the other is 4x minus 5. You've been changing algebraic or words into algebraic expressions for years now. What's the measure of the larger angle? Obviously, this is going to be the larger angle. Okay, so we're going to find that after you solve for x, you got to plug it into that larger angle. So we have 5x minus 5 equals 180. Add the 5 across. 5x equals 185. This is all pre-algebra from 7th grade onward. And divide by 5 and you get 37. So x is 37. Do 37. Or I could plug in the 37 here and then just subtract it across. And that has to be the answer. 180 minus 37 is 143. Okay, number 11. I'm going to go ahead and erase all this here. And we'll change the color. We'll go to red now. Okay, number 11. We're solving for, I guess that's 12. 11 we just did right there. 10 was that one. Okay. Yep. All right, so it's 12. Solving for x and y. Okay, so I can go ahead and look at these x's, these 3 adjacent angles, create a line, which another word for that is a straight angle, which is 180 degrees. So they all add up to 180 degrees. So can I add numbers correctly? The rest of it is pre-algebra the rest of the way. 7th, 8th grade math. 5x, 5 and 8/9 x. And I have plus 21 equals 180. So 5 and 8 ninths becomes 45, 53 ninths. X equals 178. I multiply by the reciprocal, 9 over 53. Okay. And when I do that, 53 ninths, multiply by the reciprocal. Oh, what am I saying? 178. That's ridiculous. Basic math here, man. I'm subtracting not 1, but 21. I just subtracted 2 first. It's 21, so 159. I knew it was going to come out nicely. 53 goes into 159 3 times, cross-canceling. So x equals 27. Okay, so x equals 27. We have that solved for. Now we need to solve for y. Now, on the y's here, notice these two angles create a y right there. And isn't that the vertical angle to that one right there? So these two angles have to be congruent. Okay, so this is one way of doing it. There's multiple ways. Okay, so I plug in 27 into here. 3 times 27 is 81 plus 10 is 91. So that means, let's move this slightly over there. There we go. So I read it. 2y minus 3 equals 91. 2y equals 94. Divided by 2, and y equals 47. Okay, so x is 27, y is 47. There we go. That's one way. I could have used these vertical angles and brought this over here, and then brought this one down over here for vertical angles and hit them all creating a line. That's just a lot more work. The easiest one is to do that right there. Okay. All right, next we identify 6, 7, 8 in class. So all points on the perpendicular bisector are equidistant from the endpoint, endpoints of the segment. Gotta have that memorized, guaranteed. This one is on the DCAS. Whether it's just filling in that definition, sometimes it has been the definition, otherwise it's a problem related to it. When 3 or more lines intersect in a single point, they are concurrent. This is from constructions that we're doing. The blank construction, the 3 perpendicular bisectors, that's the circumcenter. That's the one that I drew in class. It creates a circle around the triangle through the 3 vertices. The other one's the incenter. Creates a circle inside the triangle. That comes from the 3 angle bisectors. Linear pairs are supplementary. I've said that at least 20 times in class already. And they add to 180. All adjacent angles that form a line add to 180. Notice it doesn't say how many, as many as there are. So if they form a line, they create a line all adjacent. It's always going to be 180. That's a straight angle. 2 angles that add to 90 are complementary. In an isosceles triangle, base angles are equal in measure. Don't forget, an isosceles triangle, by definition, is at least 2 congruent sides. The exterior angle of a triangle equals the sum of the 2 remote or opposite interior angles of that triangle. There we got to know both of them for the DCAS. Given a pair of parallel lines cut by a transversal, name the 4 types of angles that we discussed and their relationships. Corresponding angles are congruent or equal. AIA, alternate interior angles are congruent. AEA, alternate exterior angles, are congruent. And lastly, same side interior angles, also called consecutive interior angles, are, and we should already know this one, it starts with an S, supplementary. It's the only one that's supplementary. There are 4 types there of these 4 types. Name the theorems that you could use to prove lines parallel so far. Again, this is on your DCAS sheet as well. You got to have this memorized. It's just the converse of these first 4 up here. So converse, I'm just writing CONV of AIA theorem. Converse of AEA theorem. Converse of corresponding angles postulate, and converse of SSI theorem, also called the consecutive interior angles theorem. Okay. Now we go ahead and use this to answer problems 2026. Name all the angles that are equal in measure. Well, A is congruent to D because of vertical angles. D is congruent to E. You have alternate interior angles. E is congruent to H, vertical angles. You could also go on A is congruent to E, and D is congruent to H by corresponding angles postulate. So we have angle A congruent to angle, oh, these are lowercase because these have letters. It's like putting a number there. Usually it'd be numbers, but in this case, I put lowercase. So A equals D equals E equals H. And then, of course, we have the other ones that are also congruent. Vertical angles there, alternate angles there, and vertical angles there. So B congruent to C is congruent to F, is congruent to G. From the drawing, name all the linear pairs. Okay, so linear pairs. We got A and B, A and C. That's from A. From B, we already did B and A, so we have B and D to add to that. From D, we've already done B, so we just have C to add to that. From C, we've already covered A and D, so they're done. Now the next group down here, E and F, E and F, E and G, F and H, and G and H. So 1, 2, 3, 4 there, 1, 2, 3, 4 there. Okay. All right. Here we have our our exterior angles theorem. You did a ton of practice on this. Guaranteed this is going to be on the DCAS test. Problem just like this with different numbers. We know the exterior angle equals the sum of the 2 remote interior angles that you've already filled in vocab-wise. So we have 10x minus 20 equals, I'm just combining like terms now, 9x minus 5. Subtract the 9x across, you get x, add the 20 across, 20 minus 5 is 15. So he says solve for the variable. Yes, we're done. 15 is the answer. All right, let's go ahead and go back up here now. Here we have parallel lines because we have our arrows from there. Cut by a transversal. Alternate interior angles are therefore congruent. So M equals 46. I told you the most popular one with parallel lines cut by a transversal is alternate interior angles theorem. Here we have parallel lines cut by this transversal right here. So alternate interior angles are congruent. So J equals 92. So we know 92 there. We have 46 here. Okay. So for K, you could just go ahead and say 92 plus 45. Subtract that from 180 because of the triangle sum theorem. So it's 137 plus K equals 180. Subtract the 137 across, and I get 43 for K. Okay, up here, I can continue this, extend this, that is, extend that right there. Okay. I have 18 degrees here. I have alternate interior angles here, so it's 98, which makes this 82. 82 and 18 is 100, so that makes this one right here 80 degrees. And then 80 and the H form a linear pair, so that means they're supplementary, which means they add to 180, so that makes H equal to 100 degrees. Okay, so you got now your linear pairs, alternate interior angles. On that, extending them. Oops, we got to go back and answer these ones. Corresponding angles, alternate interior angles. C and F, D and E. C and F, D and E. You're supposed to already have these memorized. If you're not, you haven't been doing flashcards and you haven't been studying. Again, off to a bad start then. Not following directions over and over. I told you a ton of times. Okay? You choose to learn, you choose to fail. Name the corresponding angles. You get A and E. There's one. You got C and G. There's two. You got B and F. 3. And last one, D and H. Of course, you've already done all this in class. This is all review. You're supposed to have these memorized. Better start doing it. Alternate exterior. They have to be outside and they have to be diagonal. So A and H, B and G. A and H, B and G. Okay. Down here, same side interior angles for 22. C and E, because they have to be on the same side of the transversal and interior. And D and F. Name the vertical angles. Vertical angles. A and D. D and C. E and H, F and G. Okay. Given the diagram with the right, prove that measure of angle W equals the measure of angle Y plus Z. Okay, so we haven't talked about proofs yet, so you're not going to see one of these on your test, but just so you know, statement, reason, and I always call them justification because that's what they were called up until the last few years in all the books for years. Justification, justify. Okay. So prove that angle W equals Y plus Z. So this goes back to right now we know measure of angle W equals measure of angle X plus measure of angle Z by what? Exterior angle theorem. Exterior angle equals the sum of two remote interior angles. So exterior angle theorem. Okay. Well, that's close. We have the W there, we have the Z there, but we need to be Y. How can I make somehow, yeah, how can I substitute that Y in there for the X? Well, I should recognize vertical angles right there. So I can say the measure of angle X equals the measure of angle Y, vertical angle theorem. We've already talked about this. You've already done vertical angle theorem over and over. And now I can say the measure of angle W, which is always your last step. Whatever you're trying to prove is always your last step. You write it exactly as they give it to you. So measure of angle Y plus measure of angle Z. And that's going to be by substitution. I substituted that Y in for the X. Okay, so that's substitution. And there'd be a little mini proof. You're not doing that yet, but there it is. All right, over here now. we can go corresponding angles. So that's 65, which then makes this 115 by linear pair. Okay, that 115 will make it 65 down here. Oops. Well, 65 here. And 65 make this 115 here. Same side and interior angles are supplementary. Okay, if you wanted that, you'd have 88 right there for vertical angle theorem. You already have a 90. All quadrilaterals add to 360. Okay, so you have 90 plus 88 is 178, 278, 288, 293 plus C equals 360 degrees. So it makes it 67 degrees for C. Okay, solving that for C. A, we already have is 115. B, we know this forms a linear pair, so that's 115. D, okay. D I can get from this linear pair right there, so that makes it 23. We've got to add to 180. Okay, 115 there. E has to be 115, vertical angle theorem, right there. F, we'd come over here. These form a linear pair, so that's going to be 124. Okay, this is a vertical angle right there for 56. This D was 23. That's its vertical angle. Right there, 23. I add those two together, use triangle sum theorem. That gives me 79 from 180 is 101 for G. Okay, then 101 can jump here for corresponding because they're parallel, which makes H 79. 79 can jump to right here for I, so that's got to be 79. 79 can jump to right there, and then I have a linear pair, which makes L 101. So you're practicing all your different types of angles. You're going to have something like, you're going to have a problem like that on the test. It's just not 10 variables as you just filled in here. You might fill in 4 or 5 only. Okay, but the same idea. Let's go ahead and just go across here. In the diagram, ray, GH bisects. That's why you see the congruent symbols right here. Bisects means splits in half. So that means they're equal. So some equal each other. Subtract that across, x. Add the 14 across, 11. So x is 11. 33 minus 3 is 30 degrees. So each of these is 30 degrees. So A says solve for x, it's 30, and the measure of angle FGH is, x is 11. So let's actually write it. X equals 11, and measure of angle FGH equals 30 degrees. Measure of angle HGI, 30 degrees. Measure angle FGI, the entire thing, 60 degrees. 30 plus 30 is 60. That's the angle addition postulate. When you add the two angles together, adjacent angles to make the big angle. All right, 35. Angle RQS and TQS are a linear pair. Okay, RQS and TQS. TQS right there. Where RQS is 2x plus 4 and TQS is 6x plus 20. Linear pair means they are supplementary, which means they add to 180. So I have now 8x plus 24 equals 180. Subtract the 24 across. This is all pre-algebra. 156 and divide by 8, and I get 176 is 9, 72 is 4 left, so it's 0.5. X equals 19.5. Working on my mental math skills. You can just plug in a calculator. Okay, so that was the answer for that one, 19.5 for A. And then it says find the measure of each of the individual angles. So now we take that 19.5 and substitute into that one to get that angle. Double that is 39 plus 4 is 43 for RQS. And I could plug it into that, or I could say 180 minus 43 is 137, which is what I would get if I plugged it 6 times 19.5 and then plus 20 in the calculator. For what value of x is D parallel to E? Well, so I have to recognize D and E right here. I need them to be parallel, which means I have to know the names of these two types of angles to one another. These are same side interior angles, and we know they are supplementary, so they must add to 180. I'm just going to combine terms right now. 9x equals 180. So x has to equal 20. If it does, then those two angles are supplementary, which means then those two lines are parallel by the converse of the same side interior angles theorem, or converse of the consecutive interior angles theorem. Same thing. So x is 20 to make that happen. Okay. Over here on 32, let me erase all this. We are identifying as true or false. Again, there's not true or false on here. You actually will name these types of angles. Okay, so you got to practice on that on problem 1, 2, and 3. Now you're just using the numbers here. 1 and 5 are adjacent, means next to. Yes, they are. 3 and 5 are vertical. No, they are not. This one does go straight across, creates one line, but that one doesn't go straight through to create the other line needed to be vertical, so false. 3 and 4 are complementary. No, they're not complementary. That means they add to 90. 1 and 2 are complementary, so these two words are switched. That's a common error students make. 3 and 4 are supplementary, and 1 and 2 are complementary. So both of these are false. Over here, we just did 36. Okay, scroll it down here. Okay, 33. Name the angle or angles in the diagram described by each of the following. Supplementary to AOD. So there's AOD. Supplementary means it has to add to 180, which we know is always going to be placed with a linear pair. So what's the linear pair to AOD? Well, that's going to be DOC right here. Angle DOC or COD, same thing. So there's that answer. Erase that now. Adjacent and congruent to AOE. AOE is 90 degrees, so it must be 90 degrees over here. This one right here, EOC. Okay, erase that now. Supplementary to EOA. EOA. Supplementary means they add to 180. Well, that could be this linear pair right here again, EOC. I can use EOC again, right there, COE, same thing. Complementary means they add to 90 to EOD. EOD, that's 60. I need it to be a total of 90. That's going to be COD or DOC, same thing. And lastly, a pair of vertical angles. Here's my pair of vertical angles right there. So I have angle DOC and angle BOA. There's my vertical angles. And you will have to do that kind of thing on your test. All right, 37. Which pair or which statement proves A is parallel to B? So we move it up a little bit so you can see right there. Okay, here's A and B. So we want these to be parallel. 8 is supplementary to 12. 8 and 12, these two angles. So how you know which two would be parallel is the two. So notice how both angles touch this transversal, touch this line right here. Okay, that means that's the transversal, the one that touches twice. The one that, when I draw my arc, only touches once, which only touches once is this one touches right there, and this one touches there. So in this case, that one proves that X is parallel to Y. Okay, if they're supplementary. So that's not what we want because we want A to B. All right, let's look at 1 and 6. 1 and 6, vertical angles. Is that one of the ways of proving lines parallel? No. We've already written down earlier, converse of AIA, AEA corresponding and same side interior angles, also called consecutive interior. So that's not even a possibility. 10 and 11 are supplementary. This one and this one. Okay, well, there's my transversal then, and then there's my two parallel lines. They touch once right there. So there's my answer. And then let's see what's wrong with 5 and 13. 5 and 13. Those are corresponding. So, and they are congruent, so that's true. But that makes A the transversal and X being parallel to Y touching at once. So this one just proves X is parallel to Y. Okay, so you will have a problem like this on the DCAS, just so you know. They might just say which lines are proven parallel given this one piece of information, and they give you one of these pieces of information, and you have to say which lines are parallel. But pretty much you're going to have one of these questions like that on the DCAS. 38, which one proves X parallel to Y? Okay, so we're going back up. 2 is supplementary 3. Nope, that makes it A parallel to B. 6 congruent to 9. 6 and 9. That makes this the transversal. X congruent parallel to Y. That's what we want. So that's my answer. Let's check what's wrong with the other ones. 14 supplementary to 15. That proves there's my transversal, and then A is parallel to B. We don't want A is parallel to B, but that's what that one proves. And lastly, 12 congruent to 13, alternate exteriors. Again, that makes that the transversal. It touches both of them. And that makes A parallel to B. So that one makes A parallel to B. So C is your answer right there. Okay, let's go to the last page. Find Z. All right. So in order to find Z, I need to have Y, which means I have to have X. So I use the triangle sum theorem to get X. 126 from 180 is 54. Makes this 126, which I could have got that right away from the exterior angle theorem if I wanted to. And now I have a triangle sum theorem. 126 and 19 is 145 from 180, because it's a triangle sum theorem. 145 from 180 is 35. So Z is 35 degrees. Find S. We've done this in class. 1S plus 1/7 plus 1/7 is 1 and 2/7 S, and then the 3 and the -3 cancel out. All angles of a triangle added to 180. That's the triangle sum theorem. Convert that to a improper fraction and multiply by the reciprocal. All this is pre-algebra, 7th grade math, 6th or 7th grade math. Okay. And so 9 cancels the 180 20 times. 20 times 7 is 140 degrees. So S is 140. Okay. 44. One second. Do we have something up here? The first one. That is the first one. 44. Which of the following is not true when A is parallel to B? So now they're telling us A is parallel to B. Which one of these is not true? Is angle 1 and 5 congruent? Yes, they are. How about 4 and 8? Yes, they are. Is 2 congruent to 6? Yes, corresponding angles. How about C here? 1 plus 5. Is that equal 180? Or 1 and 5 same side interior angles? No, they're not. They're corresponding. So this is false. 4 plus 6 adds to 180. Yes, those are same side interior angles, also called consecutive interior angles. And is 4 congruent to 8? Yes, they are corresponding. So the one that's not true right there, C. Okay. Let's do 41 first. So there's two different problems that are not related. You do each one separately. G is parallel to H. Okay. Or use lowercase letters in naming lines if they're at the arrow. Otherwise, you pick 2 points in line. We don't have 2 points in line, so we have to use these lowercase letters to name them. So G and H are those lines, names of those lines. Measure angle 2 right here is 88. What's measure angle 3? Well, that makes this 88 over here, right? Corresponding angles, and then 88 and that 3 form a linear pair, which means they are supplementary, which means they add to 180. 180 minus 88 is 92. And then we have V is parallel to W. And measure angle 1 is 120. What is the measure angle 2? Well, we know this has got to be 120 because of corresponding, and then these are linear pairs, so that makes angle 2 60 because they're supplementary. All right, let's come over here to 45, 6, and 7. We're using this diagram up here. It says A is parallel to B and X is parallel to Y. So these are parallel and these are parallel. Okay. All right, the measure of angle 2. Well, so we can fill in this. Angle 2 has to be 125 degrees, so we have corresponding angles with this 125 right there. And the measure of angle 8. Well, angle 8 is also corresponding, so this has to be 125 also. So therefore, they're equal, which is C. So for 45, you put a C right there. 46, you have measure of angle 10 plus 6. We know 10 plus 6, these are same side triangles. That's 180 degrees right there. Whatever they are, they add to 180. We know that. Supplementary. How about 3 plus 12? 3 right here. Oh, we have to work our way around. So that's equal to that. That's equal to that. And this is equal to that by corresponding. So you have corresponding vertical angle theorem and then corresponding. So 3 and 12 are equal. Now, we don't know what, oh, we can figure out what they are. So this is 125. That makes this 55 because they're a linear pair. So that makes this 55. What's 55 and 55? 110. So therefore, column A is bigger. So it's A. All right, how about 4 and 14? Well, that's got to be 55, linear pair. And then 14, we can go 55 right here, alternate interior angles. And then we can go 55 right here, alternate interior angles. Okay, so angle 4 and 14 are equal, which goes back to letter C. Okay, so there's all that. Let's go ahead and erase that. And now we have our last few down here. What are the measure of angle EBG? EBG, right there. So that's 125 minus 80 is 45. And EBC is 100 degrees. Okay, and then classifies acute, right? Well, obviously between 0 and 90 is acute. And between 90 and 180 is obtuse. Okay, and then 43 says name the numbered angle. Here's the numbered angle in 3 different ways. So we can call it angle DBE. We can switch the order and call angle EBD. Okay, and we can call it angle 2. Why can we not call it angle B? Because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, about 10, at least 10 different angles that are associated with angle B right there. Or you can only have one if you're going to call it by a single letter. All right, so there's that. And now let's get to the last 3 here. Lines AC, AC right here. That means it extends on forever. And HF. These are what? Well, you can see they aren't going to intersect, so they're either parallel or skew. Well, remember, I can have this diagonal plane right here. So therefore, they're in the same plane, which makes them parallel. Okay. 49. Which lines are skewed to line BF? So there's BF. So that means they can't be in the same plane. How about DH? DH is in the same plane, so it wipes that one out. How about CA? CA is not in the same plane, so that one works. How about IG? IG, that's the I right there. IG also. Okay, so that will work. So that one's true. How about, so now let's go to the last one you need to check, CD. Okay, that's a different plane. They will not intersect. That's true. And GH. GH also in a different plane. They will not intersect. So that's also true. So B and C is my answer, which is E. Okay, and like I said, there's a good chance you see one about skew on the between skew and parallel, distinguishing them. Which lines are perpendicular? Remember, it's 90 degrees, a right angle to line CG. Okay, let's just get rid of all that. Okay. to CG. So there's CG right there. We want perpendicular. Okay, CD. CD is perpendicular. That's true. CA, that's perpendicular. So that's true. Okay, let's erase those again. So now we're at CG again right there, comparing it to GH. GH right there, that's perpendicular. And EF, okay, EF is not perpendicular. Perpendicular. H, that's a skew line. Okay, perpendicular is in the same plane. Okay. So I'll wipe that one out. HF now. HF. Right there. Is that perpendicular? They have to be in the same plane to be perpendicular. So are those in the same plane? No, they are not. So even though it looks like it'd be 90 degrees going down, you know, if I had it right here, then it would be 90. But we're talking about CG over here. So since they don't intersect, they're not in the same plane, they'd be parallel. I mean, skew. So that's out. Okay, so it's just A. Okay. All right, that goes ahead and answers all those questions. 41 minutes, almost 42.